The fuel consumption of a car in miles per gallon is modeled by f of 6e to the s minus s squared over, okay, where s is the speed of the car in miles per hour. Okay. Miles per gallon, miles per hour. Okay. So basically the fuel consumption depends on the speed of the car. Seems reasonable. If the car is traveling at 50 miles per hour and its speed is changing at a rate of 20 miles per hour squared, okay, so that's like an acceleration, what is the rate at which the fuel consumption is changing? I'm not really sure what the rate at which the fuel consumption is changing. So fuel consumption would be miles per gallon, and the rate of that would be miles per gallon per hour. Okay, which I think is what this is. So if you think of miles per gallon and then you divide that by hour, you can look at that as hours divided by 1, and then to divide fractions like that, you multiply by the reciprocal, miles per gallon times 1 over hour, and you get miles per gallon. Okay, so that seems reasonable. So how do we get that? Gee willikers. Okay. So we know up here, this is miles per gallon. So we want to find the time derivative of this. I'm going to call it f prime of s. That way we will have miles per gallon per hour. Okay, yep. So rewrite this real quick. So this is 6e to the s over 20 minus s squared over 400. So the derivative, this will be prime, will be, so 6 will stay the same. And then we're going to do the chain rule. So we'll do e s over 20 minus s squared over 2400. Now we multiply by the interior, which would be this part up here, which is 1 over 20, because the derivative of s over 20 is just the derivative of s times 1 over 20. Minus 2s to 400 times s prime of t. So what I did here was the chain rule. Do I need s prime here? I think I do. S prime of t. So what I did here is use this one as the example. So we know we want to take the derivative of s of t over 20. So speed with respect to time. And the derivative with respect to time will be 1 over 20 times s prime of t. So we're not really taking the derivative with respect to x, we're taking the derivative with respect to t. So we're kind of doing a double chain rule here. So you can think of this actually as f of s of t. So we have 2 nested functions as opposed to 1. But this should be the right, we just did the chain rule twice. And that's how we have the s prime of t. Okay, so now we're just going to plug in the values that we were given. This one is surprisingly in-depth. So s of t, which is the speed of the car at time t, is 50. 50 miles per hour. And s prime of t, the acceleration, is 20 miles per hour squared. And so the fuel consumption will be 6 times e. Zoom in a little bit. All right, so we have s, which is 50. 50 over 20 minus 50 squared, which is 2500, over 2400 times 20 over 20, because we got that, minus 2 times 20, which is 40. No, because that's S. So this is 2 times 50, which is 100, over 2400 times 20. So I'm going to cross this out, and this will be 2000. Okay? And I'm going to simplify things a little bit before I put it in the calculator. I'll probably actually just use Wolfram for this one because, well, yeah. 5 halves minus 25 over 24. You can do this in the calculator. I just like Wolfram, and there's nothing really gained by showing you how to do this in the calculator. You can figure it out. Ooh. 2 over, or 20 over 24. Okay. So after Wolfram, start with 6. 6 times quantity E to the quantity 5 halves minus 25 24ths. 5 halves minus 25 over 24 times, and I think it was 1 minus 20 over 24. And I'm sure I could simplify that, but I'm not going to. It's easier not to. It's kind of a balance between when to simplify and when not to, because you don't want to make a mistake while simplifying, but you also want to be simple enough that you can put it into your calculator without making a mistake. So 4.299. 4.299. Okay? Let's see if anything is closed. Aha! There's even... yes! Bing! Yes! I was really questioning myself on that one. I'll be honest, guys. Oh, there we go. So the idea here is you're given a question, you write it out, and we take what they're saying is you're given an f of s of t. So you're given a fuel consumption that's related to speed, which is also related to time. You take the derivative of that, so you take the chain rule of your e, of the exponent. But then when you have this s value, you're not taking the derivative with respect to x, you're taking the derivative with respect to time. And so when you take the derivative of speed with respect to time, you get an acceleration, which is this s prime of t we had over here, which was measured in miles per hour squared. You write it out, you plug in all the values, and then put it in your calculator, gives you an answer, and that answer is 4.299. Kazam! Yes! Go team.